Hello and welcome to another episode of the Blockchain Interest Group podcast with your hosts Krishna and Nikhil. BIG is a consortium of individuals who are interested in blockchain and distributed ledger technologies. You can learn more about us on our website big-org.com or follow us on our social media using the links in the description down below. Our topic for today's podcast is Filecoin, which aims to be a decentralized storage network that turns cloud storage into an algorithmic market for buying and selling storage space. To compare Filecoin with something in the centralized world, the best comparison would be something like Amazon AWS S3. In the decentralized blockchain space, the best comparison would be projects like Storage, Siacoin, or MadeSafe. Filecoin is a cryptoeconomic system built on top of the IPFS protocol. It uses multiple consensus mechanisms like proof of storage, proof of retrievability, and proof of spacetime, which are used to ensure that the data is stored appropriately for the duration specified in the contract. Today, we are going to be looking at how Filecoin works and how it aims to provide a decentralized market for buying and selling storage space. With that, let's jump into our discussion on Filecoin. So Nikhil, do you want to start off with the basics of what Filecoin is, the underlying IPFS network that it runs on, and the problem it is trying to solve?
Sure. So Filecoin essentially can be considered to be almost like a cryptoeconomic layer on top of IPFS. So IPFS is the interplanetary file system. It's a protocol that has been that was proposed in 2014 by this guy called Juan Benet and his team in Protocol Labs, and they basically have a working version of this IPFS file system, which is a distributed peer-to-peer file storage network that is running. Now, now they're coming out with Filecoin as this cryptoeconomic incentive layer on top of IPFS. So if you look at Filecoin, essentially it is a decentralized storage network built on a blockchain. So it has its own blockchain, which is separate from IPFS, and it has a token. The client spends tokens for storing and retrieving data, and miners earn tokens by storing and serving this data, right? So the Filecoin decentralized storage network handles the storage and retrieval requests respectively using two markets. So there is a storage market and there is a retrieval market. So you can look at the storage market as a put function. So that's usually the way the file is stored. So it's a put request from the client, and then the retrieval market basically is used to execute the get request. So the get request is when the client wants to retrieve the file. Okay. So at a very high level, so if you look at it, the Filecoin system is essentially a system that is built on this premise that anybody in the world can send a put request with a particular piece of data. And the put request basically returns back a ID. It's essentially a hash ID of that particular file or data file that was sent out. And then basically they can then send out at a later point in time, or somebody else can send out a GET request with this particular file ID to this network and retrieve that file without having to worry about where exactly the file is, right?
Okay.
And then
actually, if I could just jump in, can you actually tell how that hash of that file is generated? Like how that works? Could you go a little bit deeper?
Sure. So yeah, I'll go into that. Just one quick thing I wanted to put in also. There is a third API protocol at a high level, which is known as the manage API. It's the manage call, which basically does everything else. So essentially, manage the amount of puts that have come in, the amount of storage space that is there, making sure that the files actually get retrieved properly, are retrievable. All of that essentially is part of this manage idea. So you have, if you look at the actors in the network, you have the client, you have the miner, and you have the network itself that is standing like an intermediary that manages the whole thing. So this is more of a conceptual kind of a separation. That's not actually how, so there is no separate network, physical network kind of thing. It's more like, okay, a network of miners and clients, but this idea of a Filecoin network as a separate entity helps understand it more easily. Now to go into the minutiae of how the hashing is done. So right now, so Filecoin basically leverages the IPFS protocol, the IPFS network, to actually store the file and retrieve the file. So IPFS is a entire topic unto itself. Suffice to say, what actually happens in IPFS is that the file that is, the piece of data that is sent is broken up into multiple shards or pieces, and a tree is created of each of these shards, and the whole tree together is basically then hashed into a particular hash, and that hash ID is basically what is sent back. And that hash ID is in the form of a IPFS URL. It's a specialized URL for IPFS that can be used by any particular anybody in the network can actually, if they know that particular hash ID in the IPFS URL, can go and retrieve that particular file.
So basically anything that is built on the IPFS network, so something like Filecoin, which is a second layer built on the IPFS network, it would use the same tree structure for actually breaking down that file into small fragments, and then and then creating a hash of the main file, which is pointing to all these fragments.
Yeah, sure. So it is actually, yeah, that is true. IPFS is a standalone piece of technology. It can be considered, you can think of it like a library that you can use, right? So today, in fact, if you look at a lot of the distributed apps that are running out there, a lot of them actually leverage IPFS to store their data. You have networks like Steemit. They recently came out with a video offering called DTube that also uses IPFS. So it's essentially a open source and component and a system that is freely available. IPFS can be thought of kind of like BitTorrent. So if you remember BitTorrent, BitTorrent is still going strong. It takes about 3% of the world's internet bandwidth. But so the thing about BitTorrent essentially is that it's a pure P2P network, right? So once you get the handle of the file, if you know the magnet URL, it's a little more convoluted than a simple ID, but you can get a unique handle of a file and then put it into your BitTorrent client, and if you're lucky and the file is popular, you'll be able to download it, right?
Mm-hmm.
So IPFS can be thought of as a similar P2P network, except that unlike Bitcoin, the data is encrypted by default. So essentially, you don't know what data you have in your particular hard drive. So essentially, in IPFS, when you set up an IPFS node, you're dedicating a certain amount of space for all the IPFS activities, and then it's continuously keeping portions or pieces of files on your machine, as well as your local files are being distributed to other machines as well.
So just a quick question on that. Like, how do you see this actually playing out from, like, in the future, let's say from a law enforcement perspective? So let's say there is some content being shared on this network, which is, probably not legal in certain jurisdictions. So if it is being done through the IPFS network, if you are actually a node that is actually supporting the storage or distribution of that content, without obviously knowing that what you are sharing, and that is by design. Like how do you see this play out from that perspective?
So this has been one of the long-standing and unanswered criticisms of IPFS and Filecoin. IPFS, to a certain extent, you have the deniability that you can bring in, saying that, okay, I'm just doing this. I'm just part of a node, and I have only pieces of files. I have no clear idea what is actually inside it. That seems to be the entire argument that uh, people, the developers and folks say whenever they're asked this particular question regarding DRM and intellectual property. As of the space time, basically IPFS, once you put a particular file in IPFS, not only do you not know whose files you have on your main network, on your machine, you also don't know who actually holds parts or pieces of your file that you have uploaded. So for example, if you have maybe uploaded a drunken video of yourself, or maybe something that you regret having uploaded, there is no way for you to actually delete that with full confidence. So you cannot go to IPFS, or you cannot go to Filecoin and say, okay, delete this work, because you don't really um, know how many nodes or who actually has that, and neither do the nodes themselves. So the IPFS network essentially can be considered to be a kind of like a blockchain in the sense that data once added to it would be immutable and not they're not deletable. What it actually does basically have is a versioning system. So it is possible for you to upload a particular file ID and or a particular file, and then maybe change it and then upload a new version of it, and distribute the hash of that. And it is possible for you to for IPFS to kind of keep track. IPFS keeps track of these version changes. So at some point, maybe one way probably looking at it is trying to upload a 0 byte file, but that would be just the latest version of the file. You can still go and look at the history, right? So that is the one of the main unanswered questions about Filecoin at this point in time, in IPFS at this point of time. I'm sure they're working on ways to deal with that, because if they don't actually do that, they're going to be in violation of a lot of laws, especially in Europe with GDPR and the right to be forgotten. Yeah, those are actually serious problems with, I mean, serious legal challenges to this particular system. So
Sure.
uh, we talked about the get and the put functions. So the way Filecoin is built is that they actually create a market for storage. So this put function is basically expressed as a storage market, and the get function is expressed as a retrieval market, right? So so why are they doing this as a market, and why is there a cryptoeconomic function on top of IPFS? Why does Filecoin have to exist? Because IPFS is doing fine right now, right? So the reason why is basically the same reason that BitTorrent is still a niche thing and not the backbone of the internet as it is today, right? I mean, even today, even though it came into being so many years ago, it has still not become the de facto file storage, and it's Amazon S3 right now that has become the de facto file storage. And the primary difference between Amazon S3 and BitTorrent essentially is in the fact that um, you have an incentive in Amazon S3 to store somebody's files. So Amazon basically will store your file as long as obviously you meet all the laws and everything, even though nobody else wants your file. So you may have, for example, a picture of your 18th wedding anniversary or 10th wedding anniversary. Perhaps nobody else is interested in it, right? So if you put it on a public BitTorrent network, you will find that it's very soon you're the only person who actually has it. There
Correct.
is no other peer or no other seed that actually has it because nobody is interested in it.
Mhm.
Okay, so BitTorrent suffers from this particular problem of what's known as the tragedy of the commons, right? It
Mhm.
is only the popular stuff that is there, right? And so happens that popular stuff in on BitTorrent happens to be illegal movies and pornography. So you get a lot of that, but you don't get, say, documents about, I don't know, the Filecoin white paper, for example, right?
Right.
That is readily available. You have to really search for it. And oftentimes, even if you find a link or a magnet URL for a torrent file that has that, you find that it doesn't have any seeds or it doesn't have any peers. And the reason for that is that there is no incentive for anybody to keep it. Okay, even the popular files, even the movies of or the big hit movie of today, if you try to search for it 1 year down the line, chances are very high that you will probably not get a good. You won't be able to retrieve it very quickly, even if you could at all, right?
Correct.
And this is basically the primary reason that you want to build a Filecoin cryptoeconomic system, right? You want to actually give an economic incentive to people to retain the file, right? To keep
Mhm.
the file around. Now, IPFS to a small extent kind of mitigates this particular problem by making everything encrypted, so you really don't know what you have on your space. But by that virtue, you also it also basically makes it very easy for you to delete or remove that IPFS node from your network because you don't know what's inside it anyway, and if you're more interested in things that you're interested in, and if IPFS doesn't have that, chances are that you just delete the file, delete your IPFS node, right?
Mhm.
Uh, the On the other hand, if you have an incentive, there is a way for you to make money. You're going to be starting to connect all those old laptops and those old hard drives, going and shopping for hard drives and getting things just so that, okay, and creating this because not only are you interested not only do you want to participate in the network, you see a chance to make money as well. So obviously, the flip side to this obviously is that, okay, as soon as you bring a market and economic incentives, a financial incentives into play, you also have a tax, right? And it's a people are incentivized to try and game the system or cheat with the system. So one of the common ones is that, okay, suppose you have a service where you basically uh, say, okay, I'm going to provide you with provide a terabyte of space. So Filecoin essentially has uh, a, a mechanism on the Filecoin blockchain. There is a block or a block table or a block order table where uh, storage people who want to provide storage miners basically go and say, okay, these are the blocks that that we are making available, and these are the corresponding IP addresses of it, and this is the time that we would make this available, right? So this particular order book is then there's an order book that is basically mapped against that that particular set of blocks. so that when anybody asks for a file to be stored, order matching can be done, and you can basically say, okay, the network basically then decides, okay, fine, this is the best price, and this is the best, or a maker taker model, right? You match your price and you bid, and go ahead with the particular storage. So obviously, in this particular case, the storage miners are incentivized to over-report the amount of storage that they have, correct? So they may say, okay, I've got 1 TB of space, but in the back I have only 100 GB of space instead of 1 TB. And basically, they try to compress or deduplicate the data so that it can be stored. Um, so this is where the consensus mechanisms of the proof of replication, proof of space-time, are used, right? So the proof of retrieval, proof of space-time, and the proof of replication is used.
Right.
So this is one attack, which is basically the deduplication attack. There's also another attack where storage miner might, just to show increase its reputation and increase its particular presence in the network, might basically say, okay, I have multiple nodes on the network, and basically they send files to each other. But in reality, the data is not saved. It is basically data in the form that can be generated on demand. So that, whenever there is a challenge or a ask to show proof of the storage, the data can be generated and provided.
Right. So, in short, it's not really useful data. It's just, data created specifically for the purpose of, building a high reputation in the system.
True. So proof of this generative attack is a hard attack to defend against, and this is basically where the proof of space-time actually is useful, because it actually asks you to continuously prove and verify. And if you make the interval small enough, the generation probably becomes costly enough that that it would be discouraged. But you cannot completely eliminate it. But you can make it expensive enough that, okay, it's kind of like a sybil attack, right? Or against Bitcoin, it's hard enough that people don't want to do it, though theoretically you could.
Correct.
So basically, you have this now cryptoeconomic mechanism. We've talked about the incentive for why, or the reasons why you want to put a Filecoin and you want to put a cryptoeconomic incentive for this. So we can go into how the proof of the consensus mechanism and the markets work. Okay, so like I said about earlier regarding Filecoin, Filecoin basically has a storage market for handling the put functions and a retrieval market for handling the get functions, right? So the storage basically, both of them basically are designed in such a way that you can actually have this off-chain. Okay, you could create a layer on top of the Filecoin blockchain, because the Filecoin blockchain contains only the order book, the actual transactions that have happened, an allocation table, and support for maybe smart contracts if you want, right? And that's not something actually that's there right now, but they're planning. But this particular this particular mechanism or this particular layer can be thought of, the Filecoin blockchain itself can be thought of like a ledger, a pure ledger, right? Since it's an order book, transactions, and allocation table, it's essentially a ledger. And you can actually have the market order matching, the settlement, all of that actually happening off-chain. And basically only the actual transactions and the orders being placed on the File blockchain after this the interactions have happened, right? So you could do something like a payment channel or a state channel on top of Filecoin. But in fact, that's the intent in order for it to actually scale in terms of performance.
So the matching would happen off chain is what you're saying. And like that's probably because it's a lot faster that way and only the settlement will be done on the chain. Okay.
So basically how it works essentially is that you start with the miner, right? The miner sends out an ask, right? So he puts an ask on the order book for basically certain amount of storage, right?
Right.
And then there is a bid that is created by the client saying that, okay, I have this particular piece of data and this is the amount of money I bid for it, right? And then the order matching is done. And if there is a deal, the deal is basically recorded in transactions, right? And also when the deal is done, the miner and the client basically that particular transaction, the particular storage sector. So essentially in Filecoin, since it's leveraging IPFS, you're not going to have the whole file in any one place, right? You're going to have multiple shards of it, pieces of it in multiple places. So it's not necessary that the entire file would be in one particular machine. So what actually happens is that there is an allocation table that says that, okay, this particular file is being given this particular ID and broken up into these many pieces and given this particular ID. And this is basically part of this particular miner's deal, right? And the miner is basically then responsible. He can turn around and then put it into as many or as few machines as he wants. One thing the client can basically ask for is they can ask for a number of copies to be retained, right? So I just to make sure that there is resiliency. You can basically say, okay, I want to have my file. I want to have 3 or 4 copies of my file in multiple machines. So in case a large number of machines go offline, also there is a larger chance of your file, enough pieces of your file to be around so that you can actually recreate it, right?
Right.
Now, once you actually, once the deal is finalized, the miner basically returns the file ID, right? The hash file ID, unique file ID, and a payment is done, right? And then so the payment is done based off a challenge response. So essentially, your payment basically can be structured in 2 ways. You can either say basically, so usually when there is a storage being piece of data being asked to be stored, there's also a time element. You basically tell, okay, how long do I want to have this file stored? Is it for a month? Is it for a year? Is it for how long do I want to keep this file, right?
Right.
And correspondingly, even on the miner side, the miner basically says, okay, I will keep so much storage available, and there's a time element for that as well. So basically, they'll say, okay, I can do it for so many weeks or so many years or whatever, right? So that's these two the things also have to reconcile. Now,
just a quick question on that. So like, let's say, like the duration of storage is over and like the miner decides to, what I'm getting at is the database would still be immutable, right? Like that file would actually still exist on the network?
No, so that's where I'm getting at, right? So if you want the file to continue to exist, your orders, you should actually place orders with multiple miners, right? And ideally, your order matching should also take into account the time. So if you are asking for a month of storage for your file, then you should not be matched against a miner that has only 1 week left in his commitment. Correct. And if you are matched, then there should be a mechanism to transfer to another miner after that. So actually, so as I was saying, we can submit new storage orders. The client submits storage orders, and then get the storage miner also creates a deal. When we receive that particular payment, so the payment here in Filecoin is not like a one-time deal. It's a micro payment. Okay. So what you are doing over there is you are basically saying that, so I want this file to be stored for 1 month, correct? Now I will not pay upfront 1 month. I will basically pay a micro payment for every proof of that proof of storage from that particular miner. Okay, so basically there is where the proof of storage, the proof of retrievability, the proof of space time actually comes in, right? So what you are trying, what you would do, the contract does is basically say that, okay, for every time that every epoch, right, that particular miner sends a proof saying that I have actually your file is retrievable, it's available, and it's being stored by me. You send a particular micropayment to him, right? And the micropayments are structured in such a way that at the end of the time of the deal, right, the complete payment is made, right? And then you're free to basically start a new deal. Or if you don't want the file to be over there, you can stop, or you can close the deal, and then basically it's up to the miner if he wants to discard the block or discard the file or overwrite it with some other file as and when it is as and when he feels fit. Correct. Now there is no guarantee that, okay, your file is going to be absolutely deleted immediately, but the chances are it will be, because there is no incentive for you for anybody to retain that particular file. Okay.
Correct.
So that is basically how that the storage portion works. Now at the retrieval market, right? So in the retrieval market, you have the client placing a bid saying that I want this particular file. Okay. And yeah, so and again the miner basically says that, yeah, okay, this is an ask saying that I have this particular file, and this is the proof of verifiability of that file. And then a deal is made, and then again the data is sent in parts. You basically pay for each part of the data being sent. So since the data is in pieces, you will probably get one piece at a time, and for each piece that you send, there is incremental micropayments that are made. Okay, and then at the end of the day, when your full file is received, you have the settlement where the entire payment is created. Okay, and you can claim your micropayments. Now, what happens when either case? So what happens if your miner basically is unable to provide a proof, right? So when the miner creates a ask, right, on the order book, he actually has to put a certain amount of Filecoin against the task. He puts a particular commitment, right? It's kind of like he actually kind of like says, this is my collateral, right?
Right.
So what happens if he does not provide proof every time there is a challenge? Okay, not only does he lose the settlement, micropayment settlement, he is also liable to pay the penalty to the client.
Mm-hmm.
Okay.
Right.
So the basic so there is a strong incentive on the miner side that he maintains his storage
Mm-hmm.
availability.
Right.
Right. Now, so this is how basically at a high level how the storage and the retrieval markets kind of work in Filecoin.
So as per the
Okay.
protocol, does the miner need to like allocate certain resources as well and like
Upfront?
upfront?
Yes.
Yes. Okay.
Yeah, he does. So essentially, in the storage market, the miner creates an ask, right? And it's like a in your equities, right? You basically have a maker taker model. You have somebody uh, making a particular trade where he says, okay, fine, I have certain amount of trades to sell, correct?
Mm-hmm.
Similarly, he's basically saying that I have a terabyte of data available for use, right?
Right.
And he also puts in a collateral as a guarantee that this particular terabyte of data, he's going to make sure that whatever is put inside that is going to be retrievable for whatever time commitment that he has given.
Right.
Okay.
Mm-hmm.
So this basically is the transaction, or this is basically the commitment that he makes. And that commitment is the basis on which the buyer basically, or the client basically says, okay, here's my bid. Can you hold this particular piece of data for this particular amount of time, for this particular amount of payment?
Mm-hmm.
Right? And
Makes
then
sense.
that basically creates the deal. So when both of them reconcile, it becomes a deal saying, okay, fine, I'll do that for you.
Mm-hmm.
Okay,
Yeah.
right. So that's how that's basically how the markets work.
Mm-hmm.
So now, obviously, one of the key things is that in the Filecoin protocol that storage providers must convince their clients that they have stored the data they were paid to store. Right?
Right.
And how do we do this is basically where the proofs come in. Right.
Mm-hmm.
So there is actually a class of proofs called proofs of storage.
Mm-hmm.
And the Filecoin, the folks who behind Filecoin One and team basically have actually added variations or kind of additional consensus algorithms that they have invented in order to handle some of the attacks that we were talking about. So, like I was saying, proof of replication and proof of spacetime are schemes that are used in Filecoin. And they are part of this class of consensus algorithms, which are known as proofs of storage. Okay. So, there are other proofs of storage like provable data proposition and proof of retrievability. And basically, they actually allow the user who outsources the data to the server to repeatedly check if the server is still storing the data, right?
Mm-hmm.
Now, proof of retrievability and provable data possession only guarantee that a prover had possession of some data at the time of the challenge response. Okay.
Right.
Now, this basically still is vulnerable to these to three types of attacks. One is sybil attacks, one is outsourcing attacks, one is generation attacks. We talked a little briefly about outsourcing attacks and generation attacks before, but I'll kind of go into it right now. So sybil attacks essentially is is the attack where malicious miners pretend to store more copies than the ones physically stored by creating multiple sybil identities, but storing their data only once. So essentially, like suppose a client comes and says, "I want 3 copies of the file to be stored," right?
Right.
The miner can say, "Yeah, I'm storing 3 copies, but actually store the data only once."
Mm-hmm.
Right? He might actually say, in fact, it's possible for the client to be saying that, okay, fine, you store 1 copy and then go to another miner and say store 1 copy and a third miner. And actually, they are actually all sybils and actually mapped to one person. And
Right.
he's storing the data only once.
Yeah.
So the client basically feels that he has got the, reliability and resiliency, but it's actually not true, right?
Right.
Now, there's
So
another
basically,
attack.
basically, let's say if
Yeah, go ahead.
how this would impact is if this guy goes out of business, or let's say something happens to this guy, right? Who's providing the storage space. Effectively, the client loses out because that entire set of sybil identities, they go down together with this guy. Would that be correct?
Exactly. So, correct. And not only that, he's getting paid 3 times the amount, right?
Correct. Yeah.
Because the client is basically he thinks that he is dealing with 3 different entities and he's paying 3 different entities for 3 copies. He's paying for 3 copies, right?
Right.
But actually the data is being stored only once. All right. So it's more than just he loses out because of the resiliency. It's also because he's paying 3 times for he's getting defrauded, right?
Right.
So the sybil attacks is basically what? Outsourcing attacks is where malicious miners commit to store more data than the amount they can physically store and rely on quickly fetching data from other storage providers, right? So basically they say that, okay, I have 10 terabytes of data, but actually they don't have, and they probably have some network at the back where they are talking to somebody else to store the data, right?
Right.
That is one flavor of it. Another flavor of it is where they do some type of deduplication or compression of the data. So both of these basically are bad because he's committing, or he's saying that he has more data than he actually has, and B, because he's relying on another network, he's increasing the risk on this network and reducing the speed of retrievability, right?
Right.
Then the final one is generation attacks, which is more against the network itself, where miners claim to be storing a large amount of data, which basically, instead of actually storing the data, they are generating on demand. So if the program is smaller than the purportedly stored data, this inflates the miner's likelihood of winning a block reward in Filecoin. So as we discussed, as we said earlier, Filecoin is a blockchain by itself, right? So it has actually got a blockchain with distributed ledger that is storing the transactions, storing the allocation table, and storing the block orders, right? So you need to have a consensus mechanism to write to that particular blockchain, right? So how do you do that? And that is basically using the amount of storage. So this is going to be this is actually a proof of storage system. So the amount of storage that a miner basically has increases the likelihood. So instead of a proof of work, your proof of storage, the amount of memory that you have, basically used as a proxy for the amount of work that you've done, right? So the more, instead of having more CPU, now if you have more storage, there is a higher chance of you actually winning the block reward for writing onto the blockchain.
When you say storage, you mean like the actual amount the miner is storing rather than his capacity, correct? So like how much ever he can prove that he has actually stored.
Yeah. So in Filecoin, everything is based on what is actually being stored. So it doesn't matter how much he claims. I have so much. If a miner claims I have 100 terabytes of space, but actually has active bids or active deals going on with only 1 terabyte of space. From the Filecoin perspective, he has got 1 terabyte of space. From the perspective of winning a block reward. Okay, so it is the block rewards are basically in the proportion of how much of the miner storage is currently in use, right? So this is the reason why generation attacks becomes important, because you can actually say that, okay, all 100 terabytes of data is actually of my storage is actually being in use, when in reality that's not true. And a block reward is basically you get Filecoin for this. So obviously that's incentive to kind of do this particular attack. Okay. So these are the reasons why now a standard proof of retrievability or a provable data possession kind of a attack, consensus scheme is not enough, because these attacks would be able to bypass those, right? So they came back with what is known as proof of replication, right? It's a novel type of proof of storage where they actually take they actually allow a server to convince the user that that the data basically has been replicated to its own uniquely dedicated physical storage. Okay, and the way they do it is essentially what they do is they divide up the amount of space uh, that the miner has basically committed to a specific set of sectors. So it's essentially a set of sectors it's broken up into a set of sectors. And these sectors basically are mapped to the physical space in the miners. I mean, when he says 10 terabytes, the actual physical hard drive space, they map it to the sectors of that. And basically, when a bid or a deal is created and client submits the data, they actually say, okay, they map the number of sectors that are consumed by that particular data. And the combination of the sector and the data is actually used to do the proof. Okay, so this particular thing where you're actually tying the sector to that particular proof forces the miner to basically actually dedicate the physical space, because that's where the sector IDs are available, right? So you cannot actually use the same sector ID multiple times. Okay, so that is how proof of replication is working, right? Now, this is still okay, but how do I know that this particular person is using this particular sector for this particular data entirely for the duration that was committed, right? So when I said that, okay, when he says that, okay, I will store it for a month, does he actually store it for the entire month, or is he just moving it around,
right,
whenever it's required? So this is basically where we use what is known as the proof of space time, right? So what we are doing over there is we are actually doing essentially a proof of replication, but in a sequential manner. So the proof of replication is repeatedly run for the duration of the deal, and this array of proofs basically are what is submitted as proof of space-time. Okay. Now, obviously, doing a proof of replication repetitively and then submitting it every time for every time there is a every epoch, right? Every time period that you want to do it is obviously, it is going to bulk up your blockchain. It is going to slow things down, right? So what they have done is they actually use ZK snarks. Now that's a little further complicating it. For what they are using is they're using a ZK snark to kind of create a summary of this particular array, right? A provable summary of this particular array that they can submit, right? Along with the key and the verifying parameter. So in the beginning, what has happened when the deal is started, they're using a ZK snark circuit, and then that particular circuit is provided to the client, and the miner then basically creates the proof of replication over the time period, and periodically sends back, whenever there is a challenge, sends back the entire array of replications as a ZK snark proof to the client.
Mhm.
So the client can then make the micro payment with the confidence that during that particular entire duration, the data was replicated and available for him to be retrieved, for it to be retrieved. So the retrieval market is next, right? So the retrieval market basically allows clients to request retrieval of specific pieces of data, right? And the retrieval market miners are used to serve it. Unlike storage miners, retrieval miners are not required to store the pieces or generate proofs of storage, right? So any user in the network can become a retrieval miner just by simply serving pieces in exchange for Filecoin tokens,
Mhm.
right?
So basically, they
Uh,
move around the files on this network rather than storing them, right?
kind of like you can think of them like kind of intermediaries. So
Mhm.
suppose, for example, in the future I can be a retrieval miner. What I would do is I'd set up some kind of favorable deals with storage miners, right?
Mhm.
And basically say, okay, fine, whenever a client comes to me with this particular piece of data, I'll send it over to you. We'll have our internal deal, and then storage, the client basically doesn't have to worry about the storage miner and all that. They can just get it.
Mhm.
And it's usually useful for situations where, the client who stores it, right, is not the client who retrieves it.
Right.
Right? So maybe it's a public piece of information, or maybe it's I don't know, somebody put a blog entry somewhere,
Mhm.
right? So the as a person who wants a piece of data, I may not know the storage miner, right? Who has it, but I can go and approach a retriever who basically might keep an index or something and ask him, right? And then do that. So it's basically a way to kind of decouple retrieval from storage, right?
Right.
So so any user can become a retrieval miner. Then the retrieval market protocol basically follows a few of these requirements, right? Clients must be able to find retrieval miners that are serving the required pieces and directly exchange the pieces after settling on pricing. Means that the order book basically is off chain, right? Because you want the clients to the retrieval miners to create indexes and to do it fast and uh, get the data, right? So we basically want them to gossip quickly and send the this thing. So and then it's not necessary for the entire order book to be present. So you might have a retrieval miner that says, okay, I've got this part of it, and another retrieval miner. So that's part, the order book can be off chain, right? Next one is basically next requirement essentially is that uh, it is impossible for two parties to perform an exchange without trusted parties, right?
Mhm.
In the storage market, the blockchain network acts as the trusted party, verifies the storage using POS and all that.
Mhm.
In the retrieval market, the retrieval miners and clients are exchanging the data without it's off chain, right?
Hmm.
So how do we actually make sure that there is no how do we actually allow trust into this? Because
Right.
the blockchain is not there, right? So
Right.
we go around this by actually uh, having the retrieval miner split the data. So I told
Mhm.
you about it, he sends piece by piece, right?
Yeah.
So they actually don't send the entire file. They will send the data in multiple parts, and for each part that the client is that sent to the client, they will get a micropayment,
Mhm.
right? So if the client stops paying or the miner stops sending the data, right,
Yep.
they can halt the exchange.
Mhm. So the fragments that have been sent already, they'll effectively be useless because you don't have the whole file.
Correct. Exactly. So this is basically where to because here right now the vulnerable person is the miner, right? Because
Right.
he's giving away the data and he wants to make sure that okay he's paid,
Right.
right? And the client basically is paying after as soon as he gets the file.
Mm-hmm.
He's not paying upfront. So here again, you don't want to do this micropayments for pieces of the data on chain,
Mm-hmm.
right? So you can probably build a payment channel first.
Right.
Okay. So the Filecoin blockchain will support payment channels for retrieval, and the retrieval market essentially is off chain.
Mm-hmm.
Okay. So they can this also allows the retrieval market miners to create, like, okay, clientele and things like that, where they set up payment channels and they do all this. And then finally, final settlement has to be done on the blockchain.
So one last question to wrap up the discussion. Where do you see Filecoin progressing in terms of adoption in the real world versus, the decentralized services?
Filecoin, they came out with their ICO late last year. They had committed. They made based on their on the team and the implementation, the credentials of the team. The ICO was very successful. They made a commitment to bring out something by the end of this year. They have, on the plus side, they have, I think, one of the better white papers out there. It's very well researched, it's very well put together, and seems to make a lot more sense. But again, no production implementation as yet. Though you could argue that IPFS has been there for a while, so they have that. They're building on top of IPFS, so they have that. There was some in last year. There was some news that they might be leveraging Ethereum for their blockchain, but since it's, I think, further down when in the last conference, I heard that Warren Bennett, who was heading this particular effort, talked in terms of their own blockchain rather than leveraging Ethereum. So yeah, so I mean, that kind of gives, I guess, an overview of the decentralized storage market. There are definitely some open questions here. One major question essentially is, how do you deal with illegal content? And that's something I haven't seen a good answer from anybody, including Filecoin. Filecoin doesn't talk about it, but I would feel that would be one of their main problems, especially given that they have venture capital and accredited investors. Intellectual property and DRM is definitely going to be something that they would need to deal with at some point. But they haven't actually mentioned it anywhere on their white paper. Whether that's going to be a legal punt or whether they're uh, actually thinking about it and have a strategy for it is unknown to me at this point.
All right, folks, that concludes our podcast. We hope that you found this episode on Filecoin useful. Please leave us your comments in the comment section below. Follow us on our social media. We are on Facebook, Twitter, LinkedIn, and also we have a very active Telegram group. The links for all are in the description below. Thanks again for joining. See you next time.